Hey there. So I wanted to work through a problem using the law of signs, the ambiguous case, so you can have something to refer to when you're trying to go back over it on your own. So on the board here, you can see I've already written some information about a triangle, QZD, and I'm going to work through this problem and just show you how the ambiguous case of the law of signs works. So the first thing I want to do is take the information I'm given about the triangle, and I want to draw the triangle so I can see what's going on. So I'm going to draw QZD. So let's say Q is here, Z is here, and D is here. D is 42 degrees, so we'll put that there. And then little z is 15 centimeters, and little d is 13 centimeters. Now, if you look at this, you can see immediately that we have an angle on an opposite side and another piece of information. So we can use the law of signs here. And we're also given angle, side, side. And remember, angle, side, side is the one with the law of signs that you have to be super careful about. So we know it's law of signs, and we know it's angle, side, side. But I'm going to write side, side, angle, so I don't get in trouble for writing that. This means we have to check for the ambiguous case. Now, the check for the ambiguous case involves taking the angle that you're given, which is angle D here, and taking the sine of that, so the sine of 42 degrees, and multiplying it by the side that's not opposite that angle. So that'd be 15 times the sine of 42 degrees, and then comparing that to the side that is opposite, so 13. So what I'm going to do is grab my calculator and do this work. So let's see, I need to find 15 times the sine of 42. And it's 10.03 or so. And 13 then is bigger than that. So what that means is this opposite side here is actually longer than the height that this 15 times the sine of 42 degrees represents. So that means I can actually draw two separate triangles, one where the 13 slants outward as it's drawn, and one where the 13 slants inward, and I'll draw that one in a moment. So I have two possible triangles. Remember, the other check is if those two numbers are equal, you have one triangle and it's a right triangle. If it's the other way around and the opposite side is smaller, then there's no triangle. The triangle won't close. So I have two possible triangles here. So what I'm going to do then is go ahead and find the first triangle. And in order to make that happen, I'm just going to use the law of signs as I normally would. So triangle 1, you're going to solve normally. So the first thing I need to do is to set up my ratio of things that I know, which would be the sine of 42 degrees over opposite side, which is 13, and then take the pair that I have a piece of information in, which is little z. So that would be the sine of big Z over 15. I solve that by cross and multiplying and then isolating the sine z, and when I would do that, it would look like this. 15 times the sine of 42 degrees all over 13. So what I'm going to do now is plug it in my calculator. 15 times the sine of 42 degrees divided by 13. That gives me about 0.772. And then to find big Z, because I'm taking the sine of that, I need to do the inverse sine of that number that I just found. So inverse sine of answer. Oops, pressed the wrong button. So let me go back and get that again. Momentary pause. This, and then that, and then this. There we go. So that tells me that angle Z is 50.54 degrees. All right, so I have angle Z and I have angle D. So I can use the sum of the three angles equaling 180 to find angle Q. So when I do that, let's see, that's that number I just found, plus 42, and subtract that from 180. I get 87.46 degrees. So I have all the angles now. Now I just need to find a little q, and I do that again by doing law of sines. So here's sine of q, which I'm going to plug in that number, over little q. And I'm going to use the sine of 42 and 13 degrees. If I solve this for q, by cross multiplying and again isolating the little q, I'd get 13 times the sine of q, which I've already found, all over the sine of 42. So I want to pop that into my calculator. 13 times the sine of that number I just found, divided by the sine of 42. I get 19.41 centimeters. Okay, so that's just like a normal solving of triangles with the law of sines. Now, the second triangle. If I draw the information that I had again, which was, so this would be triangle 2. I'm going to draw the 15, and I'm going to draw the angle that I know first. So 42. And then that side, that 13, instead of opening outward, is going to have to open inward. So it's going to look like that. So that's where the 13 would go. So this is D, this is Q, and this is Z. Now you could draw these both in the same triangle and get that isosceles thing going on between this 13 and this 13. It would look like this, roughly drawn. I just like drawing it separately sometimes because I find that a little easier to work with. Now, the big deal here is the stuff that you were given in the original problem is still the same. So you still have that angle D, you still have that side Z, and you still have that side D. The thing that's going to be different here is finding that angle Z. Obviously, it's an obtuse angle in this triangle, whereas it was acute in the other triangle. Whenever you're trying to find that angle, you can use the work that you've already done in the previous part. We found in the previous part that Z was 50.54 degrees. Well, this Z is going to be the supplement of that. So it's 180 minus that angle that we found, and that would be this triangle's angle Z. So what I'm going to do is go ahead and pop that in my calculator, and I get 129.46 degrees. And then everything else proceeds just like I did the first time. This time, I'm going to use the angles summing to 180 with this number, the 129.46, plus the 42, and I'll use that to find Q, which is going to be a much smaller angle this time. So let's see, 180 minus that angle I just found, which is 129, minus 42. So Q is going to be about 8.54 degrees. Again, a small angle because Z is so much bigger than it was in the first triangle. And then I need to use the law of sines to find little q, which again, it should be smaller this time because the angle q is so much smaller. And I'll go back and do sine 42 over 15 again. Oops, not 15, 13. Always important to kind of think back through your work to make sure you're actually doing it right. If you cross multiply and isolate q, I would get this. And then when I plug that into my calculator, I get 13 times the sine of that number I just had. And I want to divide that by the sine of 42. And I get q is 2.89 centimeters. Now, one of the nice things you can do to sort of check to make sure that your work makes sense is, number one, check to make sure the biggest sides are opposite the biggest angle and the smallest sides opposite the smallest angle. So in the first triangle, the biggest side is 19.41. The biggest angle in that triangle is 87.46. So that makes sense. The smallest side is 13, and the smallest angle is angle D, which is the 42. That works. In my second triangle, the biggest side is the 15, which is opposite angle Z, which is the biggest angle. And the smallest angle and side are both Q. So we're good on that. So I believe we got this problem solved. If you have any, now keep in mind, if you actually had a triangle that didn't exist and you were working through the law of signs, the law of signs would eventually tell you, hey, something's wrong. But if you have the ambiguous case where you have two of these, you're going to have to make sure to do this check before you get anything started.